We are going to continue with chapter 8 today. These are the answers for today's questions. Questions 1. A monochromatic light is incident on a slit of width 0.24 mm. Diffraction pattern is formed on a screen placed at 50 cm from the single slit. The width of the central maximum on the screen is 3 mm. Find the wavelength of the light used. To determine the wavelength of the light used, first you need to visualize the question first. Now, questions tells you the width of the central fringe is 3 mm. What does it mean? Let's have a look at this diagram. So given the diagram for a single slit diffraction, the central width is from this N1 until the other N1. So it means the width of the central maximum is actually equals to 2y1. And it is equals to 3 times 10 to the power of negative 3 meter. Therefore, y1 is equals to 1.5 times 10 to the power of negative 3 meter. And once again, if you look at this diagram, this N1 is the N for dark fringe. Therefore, this y1 is actually the first order minimum. So now that you know this question involves the first dark fringe, let's apply the equations. Y equals to n lambda d over a. Substitute the values into the equations and the lambda is equals to 7.2 times 10 to the power of negative 7 meter. Questions 2. A diffraction grating consists of a glass plate with 5,000 lines per cm. Light of wavelength 632 nanometer is incident at normal onto the grating. A. How many diffraction orders can be seen in the transmission? B. How many bright fringes can be observed on the screen? To determine the numbers of can be seen on the screen, first you need to make sure everything is in SI unit. So given n equals to 5,000 lines per cm. Now what you have to do is to change it into lines per meter. So in order to change it into lines per meter, when it comes to this value, it would be better if you write it in fraction form. So n is equals to 5,000 lines over 1 cm. So 1 cm is equivalent to 1 times 10 to the power of negative 2 meter. Therefore, n is equals to 5 times 10 to the power of 5 lines per meter. To determine the maximum order can be seen on the screen, let's assume the angle is equals to 90 degrees. So given d sine theta equals to n lambda and d is equals to 1 over n, therefore we now have 1 over n sine theta equals to n lambda. Substitute the values into the equations, you will then obtain n equals to 3.16. But when it comes to chapter x, remember to round out the value. So now we have n is equals to third order. To calculate the numbers of bright fringes can be seen on the screen, let's apply the equations 2n plus 1. So the final answer is 7 fringes. Now, why 2n plus 1? Let's look at this diagram. According to the questions A, you have 3 order maximum. 3 order maximums means that now you have 3 maximum on either side. 3 above, 3 below. And don't forget about the central maximum. That's why we have a plus 1 in our equations. So to calculate the numbers of maximums that can be observed on the screen, we use formula 2n plus 1. So that's all for today. I will see you again tomorrow.